In this lecture, there were few observations which was experimental based on photoelectric effect. So before we discuss the details of photoelectric effect, let us discuss about the three experimental observations. The first one was from Hertz. He observed that when ultraviolet rays are incident on a negative plate of electric discharge tube, then conduction takes place in the tube by the ejection of electrons. Halbeck observed that if negatively charged zinc plate is illuminated by ultraviolet light, its negative charge decreases and it becomes neutral, and after some time it gains positive charge. It means that in the effect of light, some negative charged particles are emitted from the metal. Later on, Leonard explained that when ultraviolet rays are incident on cathode, electrons are ejected. These electrons are attracted by anode and circuit is complete due to flow of electrons and current flows. When ultraviolet ray was incident on anode, electrons are ejected but current does not flow. So these experimental observations lead to the explanation of photoelectric effect, that when the light of short wavelength or high frequency takes out the electrons from the metal surface, and which actually is linked with the formation of current, which we later on named as photoelectric current. So for the photoelectric effect, the light of short wavelength or high frequency is more effective than the light of long wavelength or low frequency, because this explanation was done by Einstein in his theory of photon when light was considered as a particle. So what is photoelectric effect? It was discovered by Hertz in 1887, rather it was observed. He found that when the negative plate of an electric discharge tube was illuminated with ultraviolet light, the electric discharge took place more readily. Further experiments carried out by Halbeck confirmed that certain negatively charged particles are emitted when a zinc plate is illuminated with ultraviolet light, and these particles are identified as electrons. So, in short, we can say that the emission of electrons from the surface of certain substances when suitable radiation of certain frequency or wavelength, which means you talk about the energy of the radiations, are incident upon it, it is called the photoelectric effect. Now, there were two theories that was established. One was based on wave theory, the other one was photon theory. But the wave theory had some defects, so finally the photon theory or the particle theory was taken into consideration to explain photoelectric effect. Now, what was in the wave theory? According to wave theory, light is an electromagnetic radiation consisting of electric and magnetic field vectors perpendicular to each other. When electromagnetic radiation are incident on a metal surface, the free electrons, which are loosely bound electrons free to move inside the metal, absorbs this energy from the radiation, and this occurs by the oscillation of electrons under the action of electric field vector of electromagnetic radiation. And when an electron acquires sufficiently high energy so that it can overcome its binding energy with the nucleus, and it comes out of the metal. So this was the theory based on wave, when light was considered as wave. But now, later on, this theory had some defect. All the properties or all the observations or results could not be explained from this wave theory. But later on, Planck and Einstein explained this considering that light is a particle, and which is named as photon. So according to this photon theory of light, consists of particles, and each particle carries an amount of energy, and this energy is equal to E is equal to h nu, where h is Planck's constant and nu is the frequency. We can also relate this equation with E is equal to hc by lambda, because frequency related with wavelength, nu is equal to c is the velocity of light divided by wavelength of light. So when a photon are incident on a metal surface, They collide with electrons. In some of the collision, a photon is absorbed by an electron. Thus, an electron gets energy h nu, and if this energy is greater than the binding energy of the electron, it comes out of the metal surface, and the extra energy given it to the electron becomes its kinetic energy. So, when you have sufficient energy, when the photon delivers this energy to the electron, some of the energy is used to take out this electron from the binding energy of the nucleus, and the remaining energy, if it has, the remaining energy is utilized to make this electron run out of the metal. So if this electron is run out of the metal and float through a circuit or float through a wire, then it produces a current, which we say is due to light, and we say photoelectric current. But the question is that why is any particular frequency or color of light is eligible to take out this electron? No, because it is clear that energy depends upon the energy. Energy should be sufficiently high. So the frequency of light should be higher, or the wavelength should be shorter, so that the energy of the photon is sufficiently large to take out this electron from the metal surface. So we discussed this photoelectric effect based on photoelectric current, and it's dependent on the stopping potential. We discuss in the next lecture.